So thank you everyone for joining us. I just wanted to give a brief presentation on some of the new features in Civil 3D 2020 and included with Civil 3D 2020, and actually with the installation package you will also get a separate executable called Storm and Sanitary Analysis. I want to go through briefly the new features in each of those for the most recent version. The first feature I want to talk about is actually in Civil 3D itself. You may be already familiar with the Analyze Gravity Network feature, or some of you may never have seen it before, but it's a feature that runs off of the HEC22 logic, and I could, well, in times past, you could take that, put in your values, your known values, say my inputs, and it would do things like resize pipes, reset inverts, calculate the hydraulic and energy grade lines, things like that. But they've made a significant update to that feature in the newest version so that I actually have, I'm able to, while I'm in the dialog, I can still move around in the drawing and look at things. That's called a modeless dialog. And it'll also, the nice thing about that is when I say select a feature in my Analyze Gravity Network, it'll actually highlight in my drawing. So it's a lot easier to work with than it was in times past. And I can also, say, preview the what it proposes to do, not only in tabular form, but I can also see it on my profile view. So it's whereas in times past it was kind of you give it the features, you run it, it would give you the results, and then you'd have to go through and kind of figure out if you want to keep them or not. I can see a preview now. I can still work in the drawing, and I can make decisions as to whether I want to keep the results or not, go back, change some variables, and then run the analysis again. And in Storm and Sanitary Analysis, the changes in there have specifically to do with the first significant one is if you're using any method like TR20 or TR55 hydrology, I can change for each subbasin now the peak rate factor so that my hydrograph hopefully looks, like it's supposed to after you do calibration. Say if you have a known storm event, maybe some flow monitors, and I can actually run multiple boundary conditions now in the same run without having to create an entirely separate model. All right. So the first feature we're going to go over is the Analyze Gravity Network feature. Now you might notice also if you haven't used Civil 3D 2020 yet, they actually changed the icons, so they're a little more, I guess, pleasing to the eye. But this feature has always been in there, maybe not so much the pretty little rainbow, but other than that, the only thing it does is it runs based on HEC22 logic. Now, if you're not familiar with, oops, that's the wrong screen. If you're not familiar with HEC22, you might be familiar with something like this, the old spreadsheet where we have to calculate our gutter spread and we check our interception rate, and maybe another one where we have to also calculate our hydraulic and energy grade lines, things like inside the pipes. If you are familiar with this method or if you're used to this method, chances are pretty good that you're already using HEC22 logic, whether you knew it or not. So if, in this case, this is actually Michigan Department of Transportation, but if your local DOT or even certain municipalities have a standard form in this format, it should be, well, I don't want to put words in their mouth, but I would be surprised if HEC22 did not work for this purpose. Now, what it does after you run, say I'm going to give it all of my parameters. Not only is it going to check my gravity network for pipe sizing and invert requirements, it's going to make recommendations on how to optimize that pipe network. So whether it, say if I have my pipes oversized, it will also look at that versus if I have them undersized. And it will generate the hydraulic and energy grade lines for me, which I can actually put right into my profile view. In my scenario that I'm about to show you, I've actually done it kind of, I guess, the more complicated way where I used catchment objects. I delineated a bunch of upstream areas to then flow to catch basins. And then we're going to talk about how to take the logic of how the catch basins flow together, some overland flow, interception rates, and we're also going to be able to actually test the efficiency of the inlets that I currently have in place. So let's get started. Okay. So here I have a simple gravity network where my catch basins are placed along my curb line on either side of the road. In this scenario, I'm going to assume that these gutter sections here are defined channels, and that anything that an upstream catch basin, like say this one, cannot intercept, it's going to flow to the next one on the same side of the road. So I numbered them so that the north side of my road has even numbered catch basins, and then my south side of my road has odd numbered catch basins. That way I can just keep an eye on when I actually set my overflow structure. I'm going to just make sure that I connect from higher to lower, odd and even. If I click on one of the structures, like my catch basin here, and I go to Structure Properties, you might already be familiar with this dialog. Of course, here's where it's going to show me my sump depth, how it's controlled, where it's located in space. Down here, I have my hydraulic grade line and energy grade line properties. This is something I'm actually going to calculate, and it's going to fill out once I run my analysis. I could, for each one of these, set a specific constant known flow, but I'm not going to do that. I'm actually going to let my catchment objects and the rational method take care of that for me. And then it shows me for each one of these, what is my road slope in the direction of flow, what's my road cross slope, what is my width, longitudinal slope along the road, etc. So there's all this information here you may have seen before, but you've never really done anything about it. I mean, you may have set, say grate width and length just so it would print on your plan, but you never actually used any of the calculations in here. So I'm going to show you that's exactly what Analyze Gravity Network is for. It takes all of that information, and then it runs it through the calculation and gives me my recommendations and my energy and hydraulic grade lines. So I could look at all of my individual catch basins like this, and I could see whether or not my parameters look correct, but I actually find it easier to just use the new modeless dialog box of Analyze Gravity Network. From here, not only can I, like I said, I can still move around and operate my drawing, but I can look at my network details. It's going to give me an entire list of all of my structures and pipes within that network. I can change the view to say just show me structures, and maybe say click on one of them, and as you can see, after I get rid of that selection, it actually highlights the structure and the downstream pipe that's associated with that. So I can actually do all of that instead of clicking on all of those dialogues independently, which unfortunately are the old moded dialog boxes where I have to change something in here before I can actually, I can't pan my drawing right now. I'm stuck in this. So I recommend taking advantage of using the new network details list, and it gives me virtually the same information presented in almost the, well, I think an easier way to read because it's kind of a table that goes across the X direction, and I can just, look at what I want. Now, I've already done a lot of setup for this. One thing I have actually suppressed right now that I will thaw is the catchments themselves. So each one of these catch basins has a catchment object associated with it. So right here, catchment 1, with a specific C factor and area and calculated time of concentration, is flowing to catch basin C. I could make sure that those are all connected by, say, if I clicked on the catchment, you might be, if you ever use catchment objects, I could click right here and assign a new one by clicking this ellipsis button and then selecting my catch basin, or I can also use my new modeless dialog box and go to tributary flow, and then I can see for catch basin 6, I'll slide this over so I can read it. For catch basin 6, I do have catchment object 1 associated with it, and I can actually just, well, I thought there was going to be a drop down. Looks like you have to type it in. It's one of the few where you actually have to type it in. Actually, you know what? I'll put a pin in that because I've not actually tried to override this, and I'm not sure if it would read it for the text or not. That was something that we'd have to test, but at least it does show me which catchment object is associated with it, and if it's, not the correct object, say again, I can select what I want. It looks like it's highlighted this one down here, and it's telling me that it's catchment object 5, and that's exactly what I want. So I'll check all of these. I will check my pipe table. So I guess the first thing I see is it's not really the end value I want. And the nice thing about this is, works kind of like the prospector where I can make changes en masse to certain values. So if I click the top one and I hold shift, I click the bottom one, as long as I continue to hold shift and click a value in here, let's say that's the value I want, it's going to change all of them that I have highlighted all at once. So you can see I have varying slopes, and that was due to, well, the profiles that I had created over here and the rules that I had set up did a lot of this for me, but I can see that instead of doing pipe drops, I'm sure you've noticed when you have a slope that goes down here, it does tend to, based on the priority of the rules, it might increase the slope, but then again, that's within my slope tolerance that I've also set in my Analyze Gravity Network. Let me select the network again. And you know what? I think you get the idea on the catchment objects, and I don't want this to get too busy, so let me freeze those first. Now we'll run the Analyze Gravity Network. I'll select any structure or pipe to bring this back up. On my Settings tab, this is actually the logic that it's going to run to when it inserts or makes a substitution for a pipe. So if a new pipe, if say for some reason this 18-inch concrete pipe right here is either too large or too small, when it inserts a new pipe, it's going to then insert a new default end value. Just want to make sure I set it here, as well as my drop across structures, my minimum cover, and my allowable velocities. So I just made sure to set my minimum velocity to still scour the bottom of my velocity. I don't want any debris to settle out, so I can make sure that it respects that with this dialog right here. Now I just need to, based on my, let's look at the, over here for my outfall. So based on my outfall location, maybe I have decided, and I wouldn't, this surface is actually water surface. Like I think this came from a DEM, so the, I wouldn't really trust this. But so I'm just going to assume that the invert here is, I can say maybe it's the water surface elevation is the average of the critical depth and the diameter of the pipe. I could also set a specific tailwater condition so that it's at the crown of my pipe, or normal depth, which is right at my invert, critical depth, etc. I'll use this for now. And then I want to tell it I don't want my outfall invert to change. So that's going to remain static, and everything else is going to be variable. Then I want to make sure that I select the right IDF curve. And in this case, I've actually authored my own that you can see here. And I'm going to use a 10-year return period. And I'm also going to turn on inlet analysis so that I can see that once I run my analysis. So I'll double check, make sure everything is set. Looks like if I look at my structures, I have a bunch of great inlets right now. Actually, let's change those. Let's change those to combination inlets for the first pass. And I'm going to have the curb opening. It turned the curb opening on, so it made the curb opening equal to the length of my grate, and then a 4-inch curb opening because I'm assuming I have a 6-inch curb. The slopes that I have here, I actually just pulled that, the longitudinal slopes. I can pull that directly from the surface. So that's why I got my slopes here. And then my gutter cross slope, I'm just assuming I have a standard 2% cross section. And then also, grate width, I've got a section for gutter width, etc. So I put all of that in these dialogues right here. Now, I've selected, let's start upstream again. I've selected all of these on this side of my road to flow to one another as overflow. That's what this portion right here is, the bypass target. So it means if anything that comes into here cannot be intercepted by this catch basin, it's going to be added to the gutter flow, and then when the interception Q is calculated for this catch basin, it's going to include not only the runoff from my catchment, but also the gutter flow in here, figure out how, based on the efficiency, how much it's going to capture, and then again, that the excess is going to be passed on to catch basin 2. To make that possible, I have to set my inlet locations to on grade. That's what this is right here. On grade tells it that it is on grade and that any overflow must be routed to a bypass target. If, however, let's say in the situation where over here, say catch basin 1, if I had unfortunately this is not the best aerial, but you would see this is kind of in the middle of a parking area. In that case, I don't have an overflow. I'm just going to actually put a depression, a local depression here, and tell it that it's on sag and force anything that flows to this area to eventually go down this catch basin. If I set this to bypass, I could bypass it off-site, but then I'd effectively be losing some of the flow in my calculation without really knowing where it's going to go. So I want to keep, in this case, I want to keep my system closed. That's why I'm going to force these last two catch basins downstream to be on sag, and then the water is just going to build up around them and eventually drain out. All right, so I'll double check. My grade opening area looks good. Curve opening looks good. Slopes look good. Got my one local depression for this catch basin. That looks okay. Everything else is right on grade. So let's run it and see how it looks. Okay, so I've run Analyze, and it shows me, not only does it recommend that my downstream pipe that goes to my outfall should be upsized to 21 inches, but it's also telling me that I overshot some of my other pipes and I could get away with 12 inches. It also shows that my pipe slopes in some areas were more severe than they needed to be, so I can actually get away with the minimum slope that I had selected for a lot of them, and then it's going to reset slopes where it might not be, and it's also going to take into account all of those rules that I showed you where it needs to maintain a 3-foot cover. So it did all that for me. I'm just going to look at it right now and say the spread, which don't be confused by this. For some reason, the spread is presented in inches. Now, I'm not used to that. I'm used to spread being presented in feet. So if I looked at this one, that's about 12 feet, which is a little bit further than I want. So we're going to want to look at this area and maybe make some changes. Before I do that, let's look at the report that this generates. So I'll run my report. It's going to be a simple CSV file. And in here, of course, because it's CSV, it's not formatted, so it's not going to look pretty until I do a little bit of formatting. But I can come down here, and since we were talking about the efficiency of the catch basins, here are all my catch basins, along with the Qs, how much it intercepted, and then right here is spread in terms of feet. Looks like that one that we just looked at was 12 feet, so I'm gonna make some changes there, and we're actually going to fix that. And then we'll double check a couple of these because it doesn't really tell me if I overshot my design requirements. So I'm going to slowly iterate down from where I picked and see kind of where my area of diminishing returns begins. One caveat about this I want to mention, it looks like that Autodesk, when they designed this, I think they calculated spread in feet as well, because that's the equation is in feet, and then they converted it to inches, but then they took this value of inches and converted it back into feet for here. So there's a little bit of error introduced in here due to the conversion, unit conversion. But you could also just take, the gutter spread equation, since this is a spreadsheet, and I could use the factors that are in here because all the information is already presented to me and recalculate gutter spread. I've submitted this observation to Autodesk, so we will see when they make the change. But until now, it is at least worth mentioning that the gutter spread right now, if you want to be very exact, you may want to recalculate it. All right, so let's go back. I want to fix this gutter spread calculation before I apply my changes. So I'll click Start Over. It's just going to go back one screen. And I am going to look at that one catch basin that's the issue, which was, in this case, catch basin 2. So I would have to look at it and figure out, is the issue coming from my overflow? Is my overflow excessive, in which case I may want to redesign my upstream catch basin? Or is the amount of area that I'm trying to drain to here creating such a large queue that I have an issue in this area? I could, I could open the curb up for outside of 36 inches to increase it, but that's going to get expensive quickly. What I really want to do is, I'm kind of curious, is instead of using this on grade, right at the grade of the gutter, maybe if this were more of a orifice flow situation rather than a weir flow, what exactly I'm going to get when that happens. To do that, I just have to set a local depression for the top of my grate. So let's find that. I actually need to go to structures because it's in here somewhere. I just have trouble finding it. So I'll come over and I will find local depression. And in this case, I found 2 feet or 2 inches was okay, but 3-inch depression. It looks like it's on an inset curb, so that should be fine. I'll just change that value, and then we'll run it again. And that spread I can live with. I can also go back and change the rest of these. Let's say we'll just take I want to keep an eye on this value, and I want to slowly iterate down and shrink my catch basins a little bit. So I'm just going to take an image to keep an eye on it. And then I'm going to, let's see what we can do. Maybe if I want to change all of these combination inlets to simple grade inlets or something. Maybe not 2, because 2 is already pretty close to standards. So I'll just make this a grade inlet. That will turn off my curb opening. All things being the same, it's still going to have the same open area. I can even, if at this point, find out if I really overshot the mark. Maybe I want to, maybe I'll change this to, I don't know, 18 by 24. Oops. Shift click, continue to hold shift, 18. And then that's going to change these areas as well. All right, so let's run this and see what we get. I'll check against my previous. My spreads look pretty good, pretty close. Introduced a bit more spread here, but I would say that's well within design tolerance anyway. So I've effectively proven that I can also, get cheaper catch basins in this situation if I wanted to than with standard, and it would still work with my design. Now we just have to button everything up. So I can, let's say, I come up here. We already know how to run the report. So I can run the report for this and save it. And I can see before I apply these changes, maybe I want to review them on one of my profile views. As soon as I click profile, a little selection of my profile view comes up. And if I look at this main profile, where everything flows to here and then comes, actually the outlet is normal to the page right here. It'll show me a preview of what it actually proposes to do with my network. It's a little confusing because for some reason, it turns on all of the other ones just for the preview. So I have all of these other catch basins that I did not have on before, and it shows them. Don't be confused by that. As soon as I click OK or apply, it's going to update my network and get rid of those. But the really nice thing is, as soon as I do click apply, it has made the changes to my network, and it has calculated my energy and hydraulic grade lines and placed them right in my profile view. I can live with that. Okay. So I think that's real efficiency gain in Analyze Gravity Network. Again, if you need to do this for road design, then perhaps that's all you really need to do. But you are limited because it is HEC-22 logic. You are limited if you are using catchments you can figure out solve for the time of concentration using the TR55 method and the surface, or you can put that concentration in directly. You could and then the Q, I should say, for that is based on the rational method. So it's nice, it's quick, but it might not be what you need. You might need to use, for some reason, a different standard than that. And that is where Storm and Sanitary Analysis picks up. Not only can I do a ton of different types of storm analysis and storm and sanitary analysis, I can also do this exact same analysis. If I wanted to, say this one, I would just hit Edit in SSA, and it would export it to Storm and Sanitary Analysis, and I could run the model in there too. That gives me the benefit of not only using different criteria, but I could run a whole bunch of different, design, what's the word I'm looking for? Iterations or scenarios. Scenarios. So I could run all those at once, and then I could actually look at them and superimpose one hydrograph next to the other to see my efficiency, as well as look at my profiles and things like that. Right here, I just have two separate subbasins that have equal area, and they have equal times of concentration. So right here, just double click. You can see I have the same area, I have the same time of concentration, but I have different peak factors right here. So when I run this analysis, and I compare the runoff from either subbasin, as long as I don't make it angry, I can see, looks like the one that I had with the default 484 peak rate factor. It's a nice bell curve with a shorter receding limb. And then I had the one that I set at 300, has less of a peak but also a longer receding limb, and the total volume of runoff for each is virtually the same. So whether it's an issue of, say, if you do this analysis and you are certain that your time of concentration is accurate, you are certain that your ground cover is accurate, you run the analysis, and then you compare that to flow meter analysis, and you find out that your hydrographs do not have the right shape. It could be a matter of the peak factor needs to be adjusted. So I can actually just have a few peak factors. Oh, I should have shown you this slide. That was actually the process with which I was going to go through for that gravity network. I'll actually mention it now. I delineated my catchment areas, and I laid out my pipe network based on where the catchment, where the low points were going to drain to. And then I assigned catchments, or I had either assigned catchments or base flows to them. And then you could use the properties dialog box if you wanted to, or you could just use the launch the analyze gravity network, and then apply the results to the pipe network. Sorry, bit of an aside. I forgot to add that last time. What I really wanted to go through is for the new features in Storm and Sanitary Analysis. You can see, based on these graphs, depending on the peak rate factor, the changes in the geometry of the hydrograph. So you can kind of see the longer the peak rate factor, the smaller the peak rate factor, the longer the receding limb. 500 is roughly what we have by default. And then a higher peak rate factor actually has a lower receding limb and a higher peak. One last feature of Storm and Sanitary Analysis allows me to, if you're the type of person who wants to run a bunch of different design scenarios at once, before and I'll actually go into the outfall. Before, when you ran a specific analysis, you would have to set a boundary condition, run it for a specific boundary condition. Say maybe I had a fixed water elevation of 400 at the output, and then I'd have the invert was all, let's say, at 390 or something like that. So I actually have my water surface elevation is above my outlet. What is that going to do to my system? I could run this scenario, save the results, and then I'd have to make a new file basically, change my boundary condition, rerun the results, and if you have to keep, flipping back and forth between different files to get the output so you could compare them, could become kind of laborious. Now I have the option of actually setting boundary conditions per outfall, or I should say per solution. So all these different files would create separate solutions. I would save that output file as its own solution file. I would give each one of these outfalls its own specific tailwater condition, and then I could open those solutions in here in the time series, and then I could look at and compare the results between them. Okay, so that's all I had. I guess we will have, let's take some questions now.
Wonderful.
Katana, are you there?
You have one question.
Yes.
Hold on. It says, can the catchments be edited like polyline or parcel?
Can the catchments be? Yes, I actually, what I had done is what I did first, I should say, is I created my catchments from polylines. So I changed my surface so that first I was looking at a watershed analysis, and then I broke down that watershed analysis boundary to, I turned on slope arrows in my surface, figured out which way it was going to flow, and then I just drew a polyline as a boundary and used that boundary as the boundary of my catchment. Now, if you're asking, can you change the geometry after it's a catchment object? Yes, you can edit the grips of a catchment, but if you have to do a large change to it, sometimes it's easier just to explode the catchment object so that it goes back to a polyline, and then you can use your trim commands and things like that to basically redraw it. I tend to find that's easier sometimes. So it depends on how much of the change.